Hello, everybody. Today we're going to look at adding and subtracting numbers in scientific notation, as well as multiplying and dividing numbers that are expressed in scientific notation. So we're going to start here today with addition and subtraction of numbers in scientific notation. So let's look at an example of addition. Let's say we have two length measurements. One of them is 2.0 times 10 to the fourth inches. And we're going to add that to a second length measurement expressed in scientific notation, 1.5 times 10 to the third inches. And I'm going to put my numbers in scientific notation there in parentheses just to distinguish them from each other to show that we're clearly adding those numbers. It makes it a little bit more obvious what we're trying to accomplish here. So the key to adding and subtracting numbers in scientific notation is that they have to have the same exponent. So right now, if we look at the exponents in the scientific notation form for each of these numbers, one of them is 10 to the fourth power, one of them is 10 to the third power. That's not going to work out for us if we're trying to add these by hand. If we put them into a calculator, it's going to work out just fine. But what we're trying to learn to do here is add these two measurements by hand. And in order to do that, these exponents have to have the same value. So we're going to have to convert one or the other. Generally, what is easiest is to take the smaller of the two exponents, that's 10 to the third in this case, and convert that number so that it is expressed in terms of the larger of the two exponents, which is 10 to the fourth. So that's what we're going to do here. The first step in adding these two measurements is going to be to convert 1.5 times 10 to the third inches so that it's expressed in terms of a 10 to the fourth exponent. Now, what I need to do to increase the number of the exponent by 1 is to move the decimal place one spot to the left. So I'm left with a coefficient of 0.15. And remember, when we move our decimal place one position to the left, it's the same as multiplying by 10. We're already multiplying by 10 to the third, so multiplying by one more 10 is 10 to the fourth. So I now have 0.15 times 10 to the fourth inches. Now, you might look at this number and say, hang on a second, isn't my coefficient supposed to be a value that's greater than or equal to 1 and less than 10? And the answer is yes. In terms of scientific notation, proper scientific notation expresses the coefficient as a number between 1 and 10. But when we're doing these types of addition and subtraction problems, it's okay that we temporarily violate this rule, because this isn't our final answer. This is just one step in the process. So we're going to ignore that rule violation for now, and we're going to correct for it at the end of the problem. So I have now converted so that my two measurements have the same exponent, 10 to the fourth. So this is what my problem now looks like. And once you've converted so that your measurements have the same exponent, it's really quite simple to add those two numbers in scientific notation. You simply take the coefficients and add them together. So we've got 2.0 and we've got 0.15, so that's going to work out to be 2.15. And then we keep the exponent, 10 to the fourth. Both of our measurements had the same exponent, so we're going to keep that exponent. We're adding, so there is no change in dimension. It's still just inches, 2.15 times 10 to the fourth inches. And actually with sig figs, this is going to round 2.2 times 10 to the fourth inches. We don't have to worry about that just yet. We'll learn about sig figs later this week. So that's an example of adding numbers in scientific notation. Now, if instead we're going to subtract numbers, it's really pretty similar. We need to still ensure that our numbers to be subtracted do have the same exponent. So for instance, if we were going to have 2.0 times 10 to the fourth inches, and now we're going to subtract instead of adding 0.15 times 10 to the fourth inches. This is the same set of measurements from our previous calculation, except now we're subtracting. Same thing, because we have converted such that the exponent is the same for both measurements, all we have to do is subtract the coefficients. So 2.0 minus 0.15 is 1.85, and we keep times 10 to the 4th inches, and we are done. And with sig figs, this would round to 1.9 times 10 to the 4th inches. But again, don't worry too much about that right now. Just focus on the process of adding and subtracting numbers in scientific notation. Once we've mastered addition and subtraction, we'll be interested then in multiplication and division. So that's what we want to look at next. How do we multiply and divide numbers that are expressed in scientific notation? And this is actually a little bit easier than adding and subtracting numbers in scientific notation, because we don't have to worry about converting the numbers so that they have the same exponent in this case. For instance, let's say we have two measurements. We're trying to calculate, let's say, the area of a rectangle, and we have dimensions of 7.0 times 10 to the negative second centimeters, and the other dimension 2.0 times 10 to the negative third centimeters. So we need to multiply these numbers in scientific notation. To do this, two steps. First, we're going to multiply the coefficients. So 7.0 times 2.0 is going to give us 14. That's the first step. The second step is to add the exponents. And in this case, we've got negative 2 and negative 3. So I have negative 2 plus negative 3, and that gets me negative 5. So what I now do is I take my multiplied coefficients, 14, and I'm going to multiply by the power of 10 given after adding the exponents, which is negative 5. And I also have to multiply the units here. So we have centimeters times centimeters. We're calculating area. That's going to be centimeters squared. So my answer then would be 14 times 10 to the negative 5th centimeters squared. Now, this is actually incorrect scientific notation, because we have a number that is greater than 10 for our coefficient. So what I would need to do at this point is to convert that to proper scientific notation. I'm going to move the decimal one place to the left. And remember, the effect of moving the decimal one place to the left is multiplying by 10. 10 to the negative 5th times 10 becomes 10 to the negative 4th. So we've increased our exponent by 1, and we have 1.4 for our coefficient. So 1.4 times 10 to the negative 4th centimeters squared would be the correct scientific notation. Let me make it clear here that that is 10 to the negative 4th. Sorry about that. 1.4 times 10 to the negative 4th centimeters squared. So that's how you multiply numbers in scientific notation. Division is pretty similar. So let's take a look at a case of division. Let's say that I have a measurement of, let's keep it with area here. Let's say we have 8.0 times 10 to the 4th square centimeters. And I'm going to divide that number then by a length. I'm going to divide by, let's go 4.0 times 10 to the 3rd centimeters. So I'm trying to divide these two measurements that are expressed in scientific notation. So similar to what we did with multiplication, the first step here is going to be to divide the coefficients. So we're going to divide 8.0 by 4.0. And that's going to get us 2.0. The second step is going to be to subtract the exponents. So in this case, I have 4 minus 3, which gets us 1. And then we're going to assemble the answer the same way we did with multiplication. We now have 2.0 times 10 to the power of 1 when we subtract the exponents here. Now we also have to divide the units. So if we look at the units here, we've got centimeters squared divided by centimeters. So one of the centimeters will cancel. And that's going to leave me with just centimeters for my unit. And unlike the previous example, this answer is already expressed in correct scientific notation. 2.0 times 10 to the first centimeters. The coefficient is between 1 and 10. So I am all done with this calculation. Now, of course, you can just put these numbers into your calculator and then get addition, subtraction, multiplication, division in a fairly simple manner using your calculator, but it is useful to know how to add, subtract, multiply, and divide numbers in scientific notation by hand. So hopefully you'll find this useful in the future.